All right, so as we look at the chain rule here, what we're trying to do is we're trying to find the derivative of a composite function. Okay? Finding the derivative of a composite function. Now, remember what a composite function is. It's something like this right here, where we have f of g of x. We have a function that's within another function. Those of you who I had last year in pre-cal honors, remember we looked at composite functions and then we decomposed them. We broke them down. The reason why we included it back then is to kind of give you a sneak preview of what we're doing right here. Okay? We want to be able to find the derivative when there's a function within a function. Okay? So for example, looking at these first three here, we're going to use the letter u to represent the inside function. And we're going to write a function f of u. Okay, we're going to write a function in terms of u to represent the outer function. Now, one of the challenging things here is to make sure that you identify the inside function and the outside function properly. Okay? Think about if you were evaluating a function, what would you do first? Okay? So, if I said evaluate a here for when x is 5, what arithmetic would you do first? If I said evaluate this when x is 5, well you plug in 5, but what arithmetic do you do first? The addition. You would do 5 plus 1 first. Right? Okay. You're scaring me here. All right. You do the 5 plus 1 first. That's the inside function. X plus 1 is the inside function. Then you would do 1 divided by 6 in that case. The 1 divided by something is the outer function. That's the f of u. Okay? So notice here, we're looking at this as 1 over something. And then the u is the something. Okay? Just stay with me. It'll catch on. You'll catch on. Okay? If I said to evaluate sine of 2x for when x equals pi over 4, what would you do first? You'd multiply it by 2, right? Okay. So that inside function, u, is the 2x. After you multiplied by 2, then you would do what? You would take the sine of it. So guess what? The sine is the outer function. So I'm taking the sine of something, and that something happens to be 2x. Okay? And then we skip C for some reason, we go right to D. Okay? If I had tangent squared of x, what would I do first? We would do the tangent first, right? Then we would square whatever we got. So guess what? F of u is something squared. The u happens to be a tangent. Okay? Now, this is important because this chain rule says if we take the derivative of that f of u, that outer function, with respect to u. So that's what this dy du stands for here. And we multiply it by the derivative of u with respect to x, we'll get the derivative of the composite function. Okay? So, let me illustrate here with this one right down here. We have 2x minus 1 squared. Okay, so what's the inside function? 2x minus 1. All right, so u is 2x minus 1. And the outer function? It's something squared. Yeah, f of u is something squared. Okay? So, what's the derivative of f of u? It's 2u, right? What's the derivative of u with respect to x? 2. Okay? So, f prime of x is going to be 2u times 2. But do we want a u in our answer? No. So what do we need to do with the u? Substitute the 2x minus 1 back in. So it's 2 times 2x minus 1 times the 2, which is 8x minus 4, if you simplify it out. Okay? That's the actual chain rule. You take the derivative of the outer function with respect to u times the derivative of the inner function with respect to x. Okay? It'll come. Okay, so in this example here, we have y equals the square root of 3x squared minus x plus 1. Let's just review that u substitution process with the chain rule. We have here, if we rewrite the function 3x squared minus x plus 1 to the 1/2 power, okay, it's helpful to rewrite it that way so we could use the power rule. But remember, we needed to identify an outer function and an inner function, okay? The outer function is what? What is the outer function? It's the one you would do last if you were simplifying.
So it's the square.
It's the square root. Yeah, it's the square root. So we could rewrite this as y equals u to the 1/2. And I'm going to let u be the inner function, 3x squared minus x plus 1. Okay? Now, if you recall, dy dx is dy du times du dx. Okay? That was our chain rule. That was our chain rule. So now all we have to do is figure out what those two things are, and we can multiply them together to get our derivative. Okay? So, du dx, we'll start with the easier part here. Du dx is what? What's the derivative of 3x squared minus x plus 1?
6x minus 1.
Very good. 6x minus 1. Now, we need dy du. What's the derivative of something to the 1/2 power? 1/2 u to the negative 1/2. Good. 1/2 u to the negative 1/2. Okay? Now, the thing here to remember is that we don't want our answer to have u's in it. We want our answer to be in terms of x. So, we're going to now substitute back in u. So it's 3x squared minus x plus 1 to the negative 1/2 power. Okay? And now we know what dy du is, and we know what du dx is, so we can now multiply them together. Question?
Why would we put 3x minus
Because this is a u to the negative 1/2.
Okay.
So we're just substituting u back in there.
So you're not using the derivative, you're just using u as.
For this part, that's correct, yes. Where we use that derivative is here at the end. dy du is 1/2 times 3x squared minus x plus 1 to the negative 1/2 power. Now we're multiplying it by the du dx. Here's where the 6x minus 1 comes in. Okay? And we just simplify our answer. The 6x minus 1 will be in the numerator because it has a positive exponent. The 2 is down here, and I'm going to translate this negative 1/2 power into a square root in the denominator. So 2 square root of 3x squared minus x plus 1 is the denominator. And that would be our final answer for dy dx. Our derivative, yes.
Can we not just use u and without using u? Can we not just
Like have u in your final answer?
no, not just like saying that y equals u over 1 over. Not over.
This right here?
Yes. That's fine.
Are you asking, do we have to use
Yes.
u?
Yes.
No. In fact, by the end of today, my goal is that we're not having to write out all of these steps. Okay? That's our goal. If I started there, though, most of us would be lost really fast. So that's why we started out with a process like this, so you guys can see it. And you may run into ones where it's more complicated and you need to write it out just for your own sanity, to keep everything organized and neat. Because it's really easy to lose parts. But yeah, eventually we want to be able to do this without having to write down all of that part. Okay. All right. I want you guys to try these. We have 5 of them. 1, 2, 3, 4. And there's 5 columns. All right. So I want you guys, tell you what, you guys here can take B. Are you guys looking so you know who I'm pointing at?
Yeah.
All right, this column, I want you guys doing B. You guys, I want you to do C. You guys do D. You guys do E. And you guys do F. All right, and try it on your own. Compare your answer with your neighbors, and then we'll see how you do. Okay? All right. I'll record without commentary.
outside function is used as 2. Inside for
All right, how are we doing? You did all of them? Cool. Let's see here. Number 1. Or wait. What is that? Hang on, I'm having trouble seeing what's what here. 2 cosine 2x. That's right. That's right. That's right. D. Yeah, there's a negative. That's right. Do go ahead and multiply like the 2x with the 3 there. Go ahead and put that together. And that's right too. Awesome job. Great. All right, let's go over our answers here. B. What did we get? Come on, someone be brave. What's our answer?
No. Not me. No.
I got it.
What did we get?
2 cosine 2x.
Yeah, 2 cosine 2x.
2 cosine 2x.
Yeah.
You got it right.
Yes,
Okay.
correct.
Be confident. Yeah, come on. All right, good. 2 cosine 2x. How about letter C here?
2 tangent x times secant squared.
2 tangent times secant squared. Is that what you got? All right, good. 2 tangent x times secant squared x. How about D?
Negative 2 over square of 2x minus 1.
Okay. Hey, folks, please be quiet and listen. Okay. Is that what the rest of you guys got? Melissa, Emma, you guys got that? All right. What'd you guys get for E?
6x times x to the 4th plus 2x squared plus 1.
That works. You don't need the FOIL at the end, though. Okay? That's good. And what'd you guys get?
28 over 2x minus 3 cubed.
Good. 28 over 2x minus 3 cubed. Good. So, here's the work for all of those. Okay? Now, our goal is eventually to be able to not have to write a lot of this. Okay? For example, on B, eventually we don't want to have to write all of this. On C, we don't want to have to write all of this. On D, we don't want to have to write all of this. Now, I'd rather you get it right than try to write as little as possible and then mess it up every time, okay? So this is going to take practice, all right? But that's our goal, is to be able to, rewrite this as 2x minus 1 to the negative 1, and then just write it as negative 1 times 2x to the negative 1 to the negative 2 times 2, and then simplify, okay? Or to jump on E from here to 3 times x squared plus 1 squared times 2x, this down here. Okay? So that's our goal for those. Are there any questions on any of those? Okay. Now, further down here, we've got a few more examples on our next page. And these examples get kind of interesting. Okay? Some of them do. Just kind of running through these ideas here. Look at A, and what strategy are you going to have to use to find the derivative on A here? Okay, we'll need to write our denominator here to the 1/3 power. So we have x over x squared plus 4 to the 1/3. Okay. What other strategy are we going to need to use here for this one? Okay, our quotient rule. We're dividing here, so we're going to use our quotient rule. Okay. What's that? And also the chain rule. Because when we take the derivative of the denominator, it's a function within a function. Okay? So, we have here, our quotient rule is low d high minus high d low over low squared. Okay? So the denominator times the derivative of the numerator. So the derivative of the numerator, okay, here's our numerator. Okay, the derivative of x is just 1. Okay, our denominator, the derivative with respect to x of x squared plus 4 to the 1/3 is, and for that we need the chain rule. Okay, let's try this without writing out everything. Okay, so we need to do the derivative of the outside times the derivative of the inside, right? What's the outside function? Okay, something to the 1/3. What's the derivative of something to the 1/3?
X squared plus 4.
Okay, it's 1/3 of whatever. In this case, that's x squared plus 4 to the minus 2/3 power. Good. That's the derivative of the outside. Now we need to multiply that by the derivative of the inside, which is 2x. Okay? So you see how you can think that through. The key here is leaving this inside alone when we do the derivative of the outside. That's the number one mistake students make when they're trying to do it this way, is they take the derivative in there or something, okay?
Mr. Dixon, from the beginning, couldn't you make that to the power negative 1/3?
You could, and then you could use the product rule instead of the quotient rule. Okay, is that what you were thinking there? Yeah, you could do that as well. In fact, that's how we derive the quotient rule, is by doing the product rule with a negative exponent, and it actually comes out to be in the quotient rule. So, but we didn't know the chain rule at the time. You have to use the chain rule in there too, so that's why we didn't derive it that way. All right, now, our quotient rule. This is some good review for us for the quotient rule, okay? We have f prime of x equals low, so the x squared plus 4 to the 1/3 power times the derivative of the top, which is 1, minus the top times the derivative of the bottom. Well, the derivative of the bottom, if I simplify that a little bit, is a 2/3 x times x squared plus 4 to the negative 2/3. And that whole thing is over the bottom squared. So x squared plus 4 to the 1/3 squared. What is it when I have it to the 1/3 power and then I square it? Yeah, it's a 2/3 power now. Okay, so that's a 2/3 power. Okay? Now, question?
Yeah, the quotient rule is low times high derivative minus high times low derivative, and then what's the?
And then it's all over the low squared. So notice it was to the 1/3 power, now it's over that to the 2/3 power. Now here's where this particular problem gets a little bit complicated, because if you remember, we don't want to leave negative exponents. Okay? We also don't want to leave complex fractions. So we need to get this 1/3 out of here. We need to get this to the negative 2/3 out of here as well. So we're going to have to do some interesting factoring here. Okay? Now you'll notice we've got an x squared plus 4, and we've got an x squared plus 4 here. Okay? So there is a common factor. The key is getting the exponents worked out properly. Okay? Now you guys know when you take a common factor out, you always take the lower of the two exponents out. Well, the lower one is the negative 2/3 in this case. So I'm going to factor out, like we said, get it back on pen. I'm going to factor out the 1/3, but I'm also going to factor out the x squared plus 4 to the negative 2/3. And you're thinking, how in the world do we do that? Okay, well, let's just do it carefully, all right? First of all, there was no 1/3 here in the first term, okay? There was no 1/3 here, but I want to end up with a 1. So what do I have to multiply by if I were going to multiply the 1/3 back in order to get a 1? It's a 3, okay? I'd have to multiply by a 3. Okay? So 1/3 times 3 will give me the 1 that I have up here. Okay? Think about it in terms of multiplying it back in to get what you had. Okay? Now, I want to end up with a 1/3 exponent here when I multiply this into this first term. That's right, yeah. So we are going to have the x squared plus 4 to the first power, because negative 2/3 plus 1 will give me the 1/3. So that's kind of nice. That turned out pretty nice. All right. Now the other half of this is actually pretty easy, because we took out the 1/3. So there's an x, a 2, and an x left. And we took out this whole thing to the negative 2/3, so it's gone. So we just have x times 2 times x. So that's a minus 2x squared. That's all that's left of that second half. Okay? And then, of course, this is still over x squared plus 4 to the 2/3 power.
I didn't get how do you get minus 2x squared?
I took out the 1/3, so this is gone.
But that's 2/3.
Well, I know, that's why we still have a 2 here.
Oh.
Okay? And then this is what I took out over here, so it's completely gone. Okay?
Where'd you get the 1/3 that's going in front of the x squared plus 4? The power negative 2/3?
This right here was 2 times 1/3, right? So we have a 2 here, and we took the 1/3 out of here. Okay? If we really wanted, we could have taken the whole 2/3 out, but then this would be a 6.
Wait, do you just,
It would work either way.
how do you know what numbers to take out?
Remember, when we simplify, we don't want to leave complex fractions. We don't want to leave negative exponents. So the whole purpose of us doing this was for this step right here. Now that it's multiplication, this 1/3 is the same thing as dividing by 3. And now that this is multiplication, since this has a negative exponent, I can bring that down to the denominator and put it with this other one. So now I have 2/3 and 2/3. So now this is to the 4/3 power. Okay? Because these 2/3 came down and joined these 2/3, so now we have 4/3 on the bottom. Okay? And the numerator, I'll get to you, is 3x squared plus 12 minus 2x squared, so it's just x squared plus 12. I don't know why that turned red. But anyways. Yeah, Rebecca?
I was gonna ask, since you said you don't want complex fractions, but there aren't any complex fractions, are there?
Well, the 2/3 being in your numerator, that's a complex fraction. A negative exponent,
Okay.
yeah. A negative exponent is a complex fraction, or is a fraction, so that makes it a complex fraction as well.
I still don't get where do you get the 4/3?
The 4/3,
You move the top down.
because this was negative.
Yeah.
So then it's this times this, and they're both on the bottom. So it's now a positive 2/3 when you bring it down. And when you're multiplying things with the same base, in this case the x squared plus 4, you add the exponents. So 2/3 plus 2/3. Yeah. Okay. So that one's complicated. That one is a complicated one. I will tell you this. This idea of the common factor, it's not always going to be this complicated because you won't always have the fractional exponents. But anytime you're doing the chain rule within the product rule or within the quotient rule, you typically will have the common factor that you can pull out. Okay? That's just how it works a lot of the time.
The numerator.
I'm sorry, what?
How did you get the numerator? X squared plus
I just simplified what was in those square brackets. All right, let's try these two. What's the difference between these two? Well, it's nice, yeah, there's no fraction, but between D and E here, what's the difference between those two problems?
D is your multiplying cosines, but they're like those are two terms,
Okay.
and then E is like the one thing.
Okay, so in D we have two factors here. We have cosine of 3 times x squared. How would we take the derivative of that?
Just 2 cosine 3 x.
Nice, Angel. Good job. Cosine of 3 is a constant, right?
Yeah.
Yes.
So we don't have to use the product rule. You could, but one of your derivatives is 0, so it eliminates half of your thing. So in this case, it would just be f prime of x equals 2 times the cosine of 3 cosine of 3 times x. Now the x is to the first power. So you bring the 2 out in front, and x is to the first power.
We're using the power rule.
Yeah, that's just the power rule. Okay, and the constant multiple. E, on the other hand, what are we going to have to use for that? In the chain rule, okay? In the chain rule. Now, we do use the power rule within this, okay? But notice here what this is saying. This is f of x equals the cosine of 3x, which is squared. So that's actually a 9x squared. The cosine is not what's being squared. It's the thing that we're taking the cosine of that's squared. Okay? So now, again, let's try doing the chain rule without writing everything out. What's the outer function here?
cosine.
Cosine. What's the derivative of cosine? Negative sine. Okay? Derivative of cosine is negative sine. We're still taking the negative sine of the 9x squared. Okay? Here's the chain, though. We have to multiply by 18x, the derivative of the inside. Okay? So it's the derivative of the outside times the derivative of the inside. We'd probably want to write this as a negative 18x sine of 9x squared. I like to pull everything in front of the trig functions so we don't accidentally think it's inside the trig function. Okay? And that's it. Yep, that's it. That's our f prime of x. Okay. Let's do, oh, where'd it go? Which one am I looking for? Oh yeah, here. H. Let's do H as our last example here. Okay? We have f of theta. If you don't like thetas, switch them to x's. It's okay. We're going to use thetas a lot, but if you don't like the variables, go ahead and change them. It's okay. There's nothing, sacred about a theta. All right? So, what's our outer function here? Well, 1/4 is a constant, right? We have sine squared of 2 theta. How many functions are we working with here? Huh? 3. Good, Melissa. 3. We have the 2 theta part. We have the sine part. And then we have the squared part, right? If I were simplifying, if I said, hey, what does that equal when theta is pi over 4? What part would you do first? 2 times the theta, okay? So that's the innermost function. Then what would you do? Then you would take the sine, and then you would square it. All right, so this one we will do the u with. Okay, we're going to write this as f of theta is 1/4 u squared. Okay, now the u is also a composite function. Okay, the u is a sine of 2 theta. Okay. So, when we do the derivative of the inside, we've got to do the chain rule again. Okay? So, let's do the du dx. We don't need to write it all out now since it's just one chain rule. If I'm doing the sine of 2 theta, the derivative of sine of 2 theta, the outer function is sine, so what's the derivative of that? It's cosine of 2 theta times the derivative of the inside, which is 2. All right? Everyone with me on that?
Yes.
All right, good, Winchan. All right, get you right here with me. So f prime of theta is going to be, now we need to take the derivative of 1/4 u squared. So that's not too bad, right? That's just 1/2 u. Okay? And then I've got to multiply it by the du dx. Okay? So it's 1/2 times u. Well, u we said was sine of 2 theta. And then I'm going to multiply that by the cosine, 2 cosine of 2 theta, the du dx. Okay? So again, we're taking this u and we're plugging it in, subbing it back in. Okay? And we're taking the du dx and we're substituting that back in as well. Okay? So there's our du dx, there's our u. Then you simplify it a little bit, cancel the half with the 2, and you have sine of 2 theta cosine of 2 theta. Okay?
Where did you get the 1/2?
When I took the derivative of 1/4 u squared, I bring the 2 out in front and it's 2/4. Okay? Okay. Alright, now I'm going to record the examples we didn't get to in class in case you wanted to see these as well. Do the rest of them. Okay, so for B, we need the quotient rule. The numerator here is 3x minus 1, so the derivative of the numerator obviously is 3, and the derivative of the denominator is 2x. So if I'm doing f prime of x, I have low d high, so that is x squared plus 3 times the derivative of the top, that's the d high, minus high d low, so derivative of the bottom is 2x times the top is 3x minus 1, and this is all over low squared, so x squared plus 3 quantity squared. So notice we didn't need the chain rule at all on this one, but we just need to simplify a little bit. So if we simplify the top, we've got a 3x squared minus 6x squared, so that's a negative 3x squared. We've got a plus 2x, and we've got a plus 9, all in the numerator. The denominator is still the x squared plus 3 quantity squared. Don't FOIL that out. Okay, next is C. This one is a chain rule. Notice the inner function here is 3x squared. Oops, 3x squared. There we go. So the u is 3x squared. The du dx, or u prime, is 6x. So when I'm doing f prime of x, the derivative of the outer function, the cosine, is a negative sign, and it's still of 3x squared. And then I multiply by the derivative of the inside, which is 6x. So I could rearrange that to make it look a little nicer, and it's a negative 6x sine of 3x squared. Alright, now for D, we've got cosine squared x. Remember, this means that it's the cosine of x squared. So the outer function is the square. So this one definitely is the chain rule. We have something squared. The derivative of something squared is 2 times something to the first. And then we have to multiply by the derivative of the inside. The inside's the cosine, and the derivative of that is negative sine. So put it all together, we've got a negative 2 sine x cosine x. If we really wanted, we could keep going and make this a negative sine of 2x, if you remember your double angle formulas, but you don't have to go that far. For right now, you can just stop there. Okay? And let's do our last one over here. Square root of cosine, which of course is cosine x to the 1/2. So very similar to the last one we just did. F prime of x, the derivative of something to the 1/2 is 1/2 times that something to the negative 1/2, and then we've got to multiply by the derivative of the inside, which in this case is negative sine again. Okay, simplifying this, we want to make sure we simplify the negative exponents. So this is going to be a negative sine of x over 2 times the square root of cosine x. Okay, so that's the rest of our examples for this one.